I'm going to make a top-down twin-stick shooter in 3D. Twin-stick shooter. Oh, 3D scene. Save the scene. Main. Run. Whoa! Look at my game. Best game ever. Alright. I want to add a ship. I have a ship model in another project. Yoink. Alright. Now I have this. Woo! You can put that back to the center. And I made this in Blender. And let me pop that open real quick just to show one thing about designing models. You have to make them such that positive Y is forward, because when it comes into Godot, then it'll be facing forward, where forward is negative Z. So positive X is right, positive Y is up, positive Z is actually backwards. So I just dragged the GLB into my scene. I need to edit this scene, open anyway, click on the mesh, save branch as scene, spaceship, close that. I can delete that node. Now I have this mesh in TSCN format. I'm going to make a new folder, meshes. I'm going to put material, spaceship in there. Make another folder after. This is the one that's actually going to have the code on it. New scene, ship. Make the ripped out of a kinematic body. I'm going to have, actually I need to get rid of that. You can't just drop in a mesh instance. Well, maybe I can. Well, load meshes. Nope, it's not going to let me. Let me delete that node. So then I'll just go into meshes and drag in spaceship.tscn. That's the actual mesh. See? Put the transform back in the middle. And then to make my colliders, I'm going to click, with the mesh selected, I'm going to click the mesh button up here and click create multiple convex collision siblings. And that creates all these pieces. So I have an engine, rear, fuselage, wing right, wing left. And this gives me pretty accurate collision that really fits the model instead of just placing in like a capsule in a box or something like that. So now I want to make this actor, put that in there, make that my player. Center it again. Need a camera. Bring that up. And rotate it down. There we go. Woo! Look at my game. Best game. Alright, I need it to move. So this is going to be a twin stick shooter, which means the left stick is going to actually move the thing. Grab the ship. So the left stick is going to move. Going to go around like that, and then the right stick is going to turn. So like if you have your right stick, it's just going to face in the direction that your stick is facing, and then obviously it'll move independently of that. Oops. Why do I have both of these selected? rotate this again. Oops. Okay, back to normal. Save. All right. So I need two different sets of 4 directional input. I need one set of 4 directional input for moving and a separate set for looking. For moving, I'm going to use cardinal directions. W. And I'm also going to use the left stick up. Set the dead zone to 0, and I'll explain why in a minute. Actually, no. I'm going to demonstrate what's wrong with that. So let me set it back to default. I'm going to make the rest of these north-south. S. Left stick down. East. D. Left stick right. And west. A. Joy axis left, stick left. All right. So those are my movement keys. And on the ship, I'm going to add a script. I need 3 variables. I'm going to export them so I can see them in the inspector. I need a speed, 15. I need a dead zone. I'll explain that in a minute. And then I need a turn factor. This is for slurping the turn. Alright, so the first thing I want to do is create a vector out of my movement inputs. So I'm going to say var move horizontal equals input.get action strength. I'm using cardinal directions, so horizontal, it's going to be east versus west, or east minus west. Vertical, I'm going to do, let me see. Yeah. So in Godot, since moving forward is going negative in the z direction, it's kind of the same as doing 2D, where going up is negative in the y direction. So I guess that's why that's similar. Let me go back and once again center that thing back on there. So I need down minus up, since up is going to be negative. So that's north. South minus north. Make a vector. I'm just calling move vector 3, where the x is move horizontal, the y is nothing, and then the z is move vertical. I'm not going to normalize it because I want to use my analog stick. And then we're going to move and slide. Now if I go ahead and run this, I'm going to turn my controller on. Oh, that is tiny. Why has that happened? Oh, I know. I forgot to multiply that times speed. I think so. Yeah. Nope. Whoops, what's going on? There we go. There we go. All right. So first of all, when you press 2 directions, you actually go faster. So I need to normalize that. That length squared. So that fixes that problem. So now my movement vector can only ever be as big as 1. And let me try the stick. That seems okay. But you can notice very visibly that diagonal motion with an Xbox One controller it's slower than horizontal or vertical movement. And this is because of a problem with the way Godot's dead zones work, which is this. The dead zone is actually square. So I used to think that the strength of an input, once you get past the dead zone, it would take the absolute value from 0, but it doesn't. It actually subtracts the dead zone from your input. And since the dead zone is independent on each axis, it ends up being a square shape. It's not that big of a deal when you have just like the keyboard keys, because let's say you're holding W and D to go in the top right. Your input length is greater than 1, and then you shrink it back down to 1, right? But when you're using a joystick, since it's a circle, you can't actually get that far. And since the input strength is whatever the joystick is minus the dead zone, you get a stronger value in the cardinal directions versus in the corners. Because you can see here, the diagonal is having the corner of a square cut off versus the horizontal just having the side of a square. You're losing more input strength in the diagonal, which is why I don't use Godot's built-in dead zone. So I'm going to go back to my settings, to my input map, and I'm going to set these dead zones to 0. And that will give me the actual value of my input. So if move.length squared is less than or equal to the square of the dead zone, then it's zeroed out. And I want to make that an ls. So if the length squared is less than the square of the dead zone that I set up here, then I'm just going to zero it out. I'm going to manually just erase the entire input. Otherwise, we're going to make sure it's clamped to strength of 1 and then move by it. So now, diagonal motion is the same as cardinal direction motion. And the arrow keys still work, or the W, S, and D keys. All right, the next thing I want to do is 8 directional movement with the arrow keys. Looking, and then also enabling the right stick to turn. So arrow keys and right stick for turning. And the way I want to do that is not with Euler angles at all. I actually want to take the vector that my stick is making, or my keys if that's the case, and look at this vector. So this is the local space coordinates for the ship. So whenever I turn, you can see that this is actually the local z axis. It's called the z basis. That's transformed at basis.z. And that's just pointing straight backwards with regards to the way I'm facing. So if I just take my input as a vector, then invert that into the opposite, then I have my desired z basis. I already have a y basis, which is the one that I currently have. I'm just going to take and reuse my basis.y. And if I cross product the basis.y with the basis z that I want, that generates the x basis. And then I have all 3 of these vectors. And from all 3 of these vectors, I can just build a new basis, which describes orientation and scale. I'll just build that one every frame and assign it to my basis, and that will turn me. So let me show. First I'm going to put all this under process movement. Just compartmentalize my code. And then I want to do process turning. So I'm going to take my input, build a vector out of it, except I'm going to call it looking. And I need to remember, I need to set up 4 new inputs. So I'm going to do up, make this an arrow key. Also give it right stick up. I'm going to take away the dead zone again. Down. Key down arrow, as well as right stick down. Left arrow key, hold on. Left stick down, sorry, right stick down. Yeah, I'm doing right stick, okay. Nope, right stick left. Right stick left. And right. No dead zone. Key right. Right stick right. Save that. Go back to my code. I'm going to do right, left, down, minus up. There. Now that builds my inputs correctly. So this, I actually want to normalize. No, I don't want to normalize that. If length squared greater than dead zone squared, then look equals look.normalize. So the reason I don't normalize this is because it might be 0. And actually, that doesn't matter. So I can just do that. Now that I have my desired z vector, I actually want the opposite of that, because you can see here the basis.z is backwards. So I need to get backwards. There we go. I now need to construct my desired x basis. And like I said, I take my x basis is going to be transform.basis.y. That's my y basis crossed with my look basis. Now that I have the x and the z, and I'm just going to take and reuse the y, I have x, y, and z bases. I can just go ahead and assign transform.basis to a new basis built from x basis, transform.basis.y, and look. Now I'm going to go ahead and ortho normalize this, just in case this ever gets out of whack for any reason. So that's how you construct a new basis. See how that works. It doesn't do a damn thing. Oh, there it is. Except it's not doing a very good job of remembering the last input I gave it. I can try the arrow keys. I kind of just want to default back. Oh, what happened? Well, that's probably because when I'm giving no input, even if you normalize it, a 0 vector normalizes to a 0 vector. And if you build a basis out of 0 vectors, that includes the scale, so I think it scales it down into absolutely 0, which is a problem. So what I want to do is cache my look, the last look input I gave it, forward, make that a persistent variable, get a temporary look, and then only if I'm actually generating a vector, then update the persistent one. So if tLook temporary look dot length squared greater than dead zone times dead zone, then look equals tLook. So this will give me a persistent vector that's always going to have a length of 1, so that I don't end up accidentally scaling down to nothing. Yeah. I still need to respect the dead zone though. Well, it should be working. I don't understand. Hold on. There we go. Alright, now the other thing I want to do is I don't want it to just jarringly jump right to that direction. I want it to slurp, spherically lerp. So I'm going to actually do, I'm going to generate a new var z basis equals transform.basis.z.slurp look. And then I want to use that to cross to get my x, because this is going to be intermediary. Oh, I need to input my turn factor. And this way I can slurp and smoothly transition to the new direction that I want to face. But there's a problem. Watch this. Oh, come on. I don't know why it's canted a little bit. There we go. So just give this a second. Now see, the debugger is starting to rack up all these errors. Let's find out what those are. Set axis angle. The axis vector 3 must be normalized. So that's firing condition, not p-axis is normalized, is true. And it's coming from the C++ source in basis.cpp at line 980 in the method set axis angle. And that's being triggered by my script on line 32. Line 32 is this line right here. Well, I'm not actually doing anything with a basis. It looks like I am, transform.basis, but I'm just accessing the z-axis, which is a vector 3, not a basis. And then I'm calling slurp on that between that vector 3 and this vector 3. Oops. This vector 3. So I did some digging, and what I found out was that this is the C++ method that's being called vector 3 slurp. That calls vector 3 rotated with the cross product between itself and your destination vector. So my destination vector is look, and so transform.basis.z is the vector 3. I'm calling slurp on that. It crosses between itself and look and feeds that into this rotated method. So rotated, vector 3 rotated takes in that cross product and it calls rotate. Rotate takes that same cross product and constructs a basis with the constructor that just takes an axis and an angle and then gets the x form. I don't understand x form, but I do understand constructors. So in the basis constructor that takes an axis and an angle, it calls set axis angle. And in set axis angle, you see it checks that the axis it's fed is normalized, and if it's not, then it fires this error. That's what we're seeing over here. The axis vector 3 must be normalized. So why is it not normalized? Well, let's go back all the way to the beginning. The first thing we do is call slurp, and what slurp does is it takes the cross between the vector being slurped and the destination. So my from and my to are being crossed, and then we feed that into rotated. That eventually ends up inside this call right here. When you have two vectors that are collinear, let me pop open paint program thing. When you have two vectors, you have one vector and you have another vector that's directly on top of it, their cross product is actually 0. It's a vector 3 where all coordinates are 0. It's the 0 vector. And the same is true when you have vectors that are collinear but they're facing the opposite directions. It's still 0. So when I have this line slurping, if I'm already facing the direction that I want to face, that means my from vector and my to vector are collinear, so the cross product between the two is going to be 0. And that's a 0 vector normalized is still 0. That eventually makes its way all the way to this call, which this is a 0 vector, and it's checking not axis is normalized. Comes back true because the 0 vector is not normalized, and that fires that error. So to avoid that error, what I have to do is first check if the cross product between where I am, transformed.basis.z, and where I want to be, look, if the cross product is already 0, then I already am at my destination. So let's just assume, first of all, that I already am at my destination. So var z basis equals look. If not, transform dot basis dot z cross look dot is equal approx vector 3 0. Then I want to slurp. All right. So right out of the gate, I just copy whatever my look variable happens to be, whatever my look vector is. We're assuming first that I already am where I am, where I want to point. But if not, then slurp towards it. See, this takes the cross product of where I am crossed with where I want to be. And if that is not approximately equal to the 0 vector, then I know that I'm not collinear with my goal vector, which means I'm not there yet, which means I need to continue to slurp. So let's run that. And now the error doesn't fire anymore. But there's another problem. You can notice that it's doing fine and slurping from this angle to this angle. It's actually taking the long way. I don't know why it's doing that. It wasn't doing that before, I promise. Anyway, if I wait a second and I let the slurping bring me to my actual destination, and then I hit 180 degrees opposite, it just snaps. And that's because this line is actually, this condition is not being met. Because I said two vectors that are collinear, even if they face opposite directions, the cross product is going to be 0. So I actually need to also check the dot product. The dot product will tell me whether or not my direction vector is exactly the opposite. So if transform dot basis dot z dot where I want to look, I actually need if is equal approx. If that is roughly equal to -1 exactly, then I know that I'm trying to point 180 degrees behind me. In which case, for just this frame, I'm going to nudge myself one way or the other. So I'm going to say, just for this frame, I'm going to reassign look to be transform.basis.x multiplied by the sign of random f minus 0.5. So what this is going to do is, if where I want to look is 180 degrees behind me, then just for that frame, I'm going to set my desired look to my x basis, but it's either going to be positive or negative, and that's going to be random. Because rand f gives me a random float between 0 and 1, and then by subtracting 0.5, it's going to be randomly between -0.5 and 0.5. And just taking the sign of that is going to give me an equal distribution of +1 or -1, which means this is going to be evenly distributed between being my left or my right. And that's only on the frame where my desired direction is exactly behind me. So I try that again. Looking straight up, give it a second to become collinear, and then press down. It spins instead of just snapping. Now I also noticed I was having a problem with this going the long way around. I'm not sure why that's doing that. It really shouldn't be. Let me make my turn factor something bigger so I can see what's going on. Turn factor 0.8. No, that's making it faster. So let me see, 0.05. Why does it do that? That's interesting. I actually haven't had this problem before. I don't know why it's being so fast. So what I want to do the inputs are being taken correctly. It's the only place slurp comes up. Turn factor. Yeah, that's correct. Spelled correctly. Oh, I see what's wrong. I'm not setting this to my Z basis. There we go. So I was setting my look to my actual input vector, and then I was using the variable Z basis to represent my slurp towards my desired direction, but then I completely forgot to plug that slurp into this function. I was just directly putting in my desired direction. So I was skipping the slurp altogether. Now this should properly slurp. Yeah, and it takes the shortest path. Cool. I can set dead zone, or the turn factor, back up to 0.2. That's a little faster. And it's a lot more responsive. It takes the shortest path each time. Wait a second. We don't have that error popping up anymore. We randomly choose a bias to either the right or the left when we turn 180 degrees. See that one clockwise or counterclockwise? Counterclockwise again, clockwise, counterclockwise. So that just demonstrates that it's randomly choosing to bias either towards the left or towards the right. In any case, when my desired input is 180 degrees opposite. Doesn't really become an issue when you're using a stick because it's hard to directly do 180. But when you're using arrow keys, you only got 8 combinations. So, especially on the cardinal directions, you don't want to end up snapping. You want to slurp. I can move, I can turn, I got twin stick motion. So now the next thing I want to do is be able to fire. So the first thing I need to do is make a bullet. Make something I can fire. I'm going to use a rigid body. I'm going to give it a mesh instance. Make that mesh instance a little capsule, and I'm going to add a collision shape. Make the collision shape also a capsule. Highlight both of those, scale them down, and make them long. And then for the mesh, I want to give it a new material. And it's going to be emissive. It's going to shoot out like a yellowish green light. Maybe a yellow light. Or maybe a green light. I know. I'm going to make it a green light. And the albedo is going to be yellow. There we go. Sort of weird looking. And then maybe in my default environment, I can do glow. Nope. I don't know what that's doing. Bloom. Does that work? No. I don't think that's doing what I want. I'm going to turn that off. I have a bullet. Alright. And so this is forward, this is backwards. That's my Z basis. I'm going to use that to impart an impulse on it later. I also want to make these kill themselves after 2 seconds or so. So I'm going to grab a timer. Time 2 seconds. It's going to be an auto start and a one shot. And put a script on this guy. Go ahead and save and close that. Put a script on this. On timer timeout queue free. So now I made that function, and I'm going to connect it up in the signals here. And the reason I wrote this manually is because since I'm using an external editor, here I'll just delete this real quick just to show you. Since I'm using an external editor, disconnect. When I try to connect a signal and I click on my rigid body and it says receiver method on timer timeout, normally this would auto generate, but since I'm using external editor, it doesn't seem to be able to do that, which is unfortunate. Timer timeout. There. And now on my ship, I want that bullet to be able to come out of any one of these 4 guns. So in my spaceship, I'm going to add spatial. And I'm going to put that right in front of the left gun there. Here we go. I'm going to duplicate it. Move that over there. So now I have one in front of my right gun, duplicate that, move it in front of that inner one, duplicate. Just want to move it on the X. There. So now I have gun left 1, gun right 1, gun right 2, and gun left 2. I'm going to make a new action in my inputs for firing. Fire. And I'm going to set that to be space or the R1 button. R1. Hold on 1 second. Hold on just a damn second. It's going to get loud. There. Now I have the R button. I'm going to go ahead and pop open my script again. Process fired. For right now, I'm going to print fired. Actually, if input is just pressed fire. Process fire. So that should allow me to fire. It doesn't do anything. Why doesn't it do anything? Yeah, spelled it right. So that should be working. There we go. So now it says fire down there whenever I fire. What I want to do is actually instantiate the bullet. So I actually want to hook up a reference to the bullet.tscn in the inspector. So what I can do here is go to the top of my script and export resource, our bullet resource, and then I'm going to print out the bullet resource.resource path and go our bullet scene, path scene. I want to say bullet scene this line here, I want to show you something cool. Since I did an export resource variable, I can now drag and drop this bullet.tscn onto the bullet resource slot. And that creates a link to that resource path. You can see in the tooltip, that's the path. Now, I'm going to run the game, and it prints out the path. Now watch this. I'm going to take this bullet.tscn, re-parent it to just the root directory. So now there it is. And now in my ship, it's still linked up. And it has updated the path, and I can just run this again, and it knows the correct path. So, using export resource variables and then loading a packed scene on ready is a really handy way of connecting resources and scenes up together without having to hard code the path, because otherwise I would have had to type load as actors bullets. Right? I would have had to type it manually, and then when I moved it, I would have had to come back into the code and erase this and then saved it. But instead of doing that, I can just set a variable up here, set that in the inspector, and then have it load that on ready, and that way it knows to keep track of this. So I moved again. There it is. And it still loads, and I don't have to worry about it. So I'm actually going to make this a little shorter by saying on ready bar bullet. And then I have to annotate this as a packed scene, because this runs during runtime, not during compile time. So it has to know what type it is. Now in my fire, I can just change this. I'm going to do rb equals bullet scene dot instance. So that allocates a new bullet packed scene into memory. Or not, actually that's a node. So B is a node, because back in here, I'll show you packed scene. Instance returns a node. So now B is a node. It just exists in memory though. I need to actually put this in my scene tree. So to put it in the scene tree, I have a reference to it. I can do get tree.root.addChild B. And before I even add this to the tree, I'm going to go ahead and assign its transform. Beta transform equals, let's see, on my ship, the path to, let's just pick one of these right now. Path to this gun port is $spaceship/gunright2. So $spaceship/gunright2 dot global transform. Run that again. So now it's going to fire as it actually drops a bullet down into space. You can see these are, since they're rigid bodies, they're being affected by gravity, which goes straight down. And they are deleting themselves after 2 seconds. Cool. But I want them to actually fire out. So the first thing I need to do is go into my project, go into physics 3D, and delete gravity. Boom, done. There, now they don't fall down anymore. But I need them to launch out. Well, first thing I want to do is change it so that they spawn out of one of any 4 of these gun ports. So to do that, instead of just hard coding this here, I'm actually going to delete that. And up here, I'm going to make another on ready guns. And then this is going to be an array. So I have that. needs to be an on ready because this $ syntax is evaluated at runtime. This refers to the scene tree. So the scene tree needs to be built already in order for these to make any sense to the program. So that's why this needs to be on ready. But once it is, I can just go back down to my fire function, and when I set the transform, I go to guns, and the index I want out of this array is going to be a random integer that's anywhere between 0 and 3. So random integer gives me a random 32-bit integer. It can be a huge number, and whenever that is divisible by 4, it's going to give me 0. And if it's not divisible by 4, it's going to give me the remainder. So effectively, this little expression gives me a random integer between 0 and 3. And those are the indices for my gun. Because this is index 0, 1, 2. So that's going to pick a random gun port and spawn a bullet. Let's make sure that works. Yep, they're being spawned in randomly. They're still not going anywhere though. So what I need to do now is I need to go into my actors, into my gun, into my bullet, not my gun. I want to give this export float variable of force, and so just make that like 25. And then I want to make fire method where we, since this is a rigid body, we can apply impulse. And the impulse that we apply to this rigid body, let's go take a look. Rigid body methods. Apply impulse. Vector 3 position and vector 3 impulse. Applies a positioned impulse to the body. An impulse is time independent. The position uses the rotation of the global coordinate system, but is centered at the object's origin. So what that means is that I can give this my bullet object's transform.basis.z, because once again, the transform basis z is behind the bullet. I want the force to appear from behind the bullet, pushing it forwards. So to make the force appear behind the bullet, we can just give it transform basis z, which points backwards. And then the direction we want that force to go is negative transform.basis.z times force. A little more space. And that should automatically, well actually, I don't think I called the fire method for this. Yeah, b.fire. There. That's the last thing we want to do is just fire that bullet. Now. Now you'll notice that some of these are spinning off into the distance, and that's because they're colliding with my ship. So I need to go into my ship, select the kinematic body, and under the physics body properties, I need to put it on a different layer. Actually, I need to go into my settings, project settings, layer names, 3D physics. I'm going to make layer 1 player, layer 2 bullet, and layer 3 asteroid. I don't have any asteroids yet, but I'm going to make them. So I'm just going to make the layer and set that up. So the player is going to be on, update that list. Player is going to be on the player layer, and it's only going to look for collisions with asteroids. Save that. Go into bullet's rigid body under physics body. It's going to live on the bullet layer. It's not a player. And then it's going to look for collisions with asteroids so that it can blow them up. And this way, it's not looking for collisions with the player. So those simply won't make any physical difference. So now I play this, and I can spin around and try to ram my wing into a bullet. Actually, what I'll do to demonstrate this even better is to temporarily not tell the bullet to fire. So if they just sit around, and I can just move through them. So collisions are no longer being registered between bullets and players because the layers in the masks are not lining up with each other. So let me go back and make that fire again. And now we're back to being able to shoot. Pew pew pew! Oh, that's random. Or it's not as random as I would like, but it's random enough. I might want to make it so I can just hold down R1, but for right now, that's pretty good. I will make asteroid objects and make them hurt the player and make them get blown up a little bit later. If I don't cut this video off short enough, then the file's going to get fucked up. So we'll just save that here and call it a day.